Hey guys, Stat 1800. First thing, in the instructional videos for August 28th, this will be the week number 2, so I don't think I'll redo the video for upcoming times when I teach Stat 1800, so whatever the instructional videos, whatever week applies to your particular class. This is being put up in fall 2017, but I intend to use this video for future courses, so keep that in mind. So what I want you to do first is I want you to come to regardless when you're taking it, I want you to come to the handout called the Contingency table, click it, and it'll download, and if you'll open it up, which I will do, you can see that we have a handout here. Alright, so I've already got the handout right here where I can actually write on it. So you're going to get sick of seeing my hand, but it's just the way things work. So guys, our focus is on categorical variables in this video, but I want to step back a little bit and take a look at a bigger picture. So we think about it, we have two types of variables, quantitative and categorical. We talked about those before, I think last week. Quantitative variables come in the form of discrete, countable, continuous, measurable. So one of our first goals in this class is after the data has been collected, we want to organize and describe it. So we organize and describe our data depending on the type of variable that we have. So to give you an example, two of our main goals in describing data is to look at tables and graphs and organize the data. And then we also want to be able to make numerical summaries. Now, quantitative variables is coming. We may get to it this week and maybe next week. But once we get to quantitative variables, if we want to make a table or create a graph, we look at a histogram or a box plot and some other things that I'll teach you. If we want to come up with numerical summaries, we look at means and medians and standard deviations and things like that. Our focus in this video, and our focus in actually the next few videos, is what if we have categorical variables? What if we're looking at gender, the type of car someone drives, eye color, political party, you name it. Anything that's categorical, the type of graph and table that we present is different. Pie charts, bar charts, Pareto charts are appropriate for categorical variables, but not quantitative. When we get into doing numerical summaries for categorical, we get into frequencies and percentages. So I got distracted by, I don't know why my wife's text come through this computer, and I wish they didn't, but I'll let her worry about that. But anyway, if I get distracted by that, just overlook me, okay? So anyway, back to numerical summaries, means, median, standard deviations. We have quantitative, contingency tables, frequencies, and percentages if we have categorical variables. So let's get our hands dirty. Let's say that we're given a sample of 316 retirement funds classified by risk level. And the risk level here are low, average, and high. And we can already see that we have our frequencies, and we also must appreciate that sometimes we call that our counts. So we have 212 low, 91 average, and 13 total for a total of 316 retirement funds. If we're going to take the percentage, it's as simple as taking the count of the risk level low divided by the total of 316 and multiplying by 100. So guys, the hardest thing we have to do here is really decide where we need to round our final answer. So you can see that 212 divided by 316 is 67, or well, 0.67088886, so on and so forth. Typically we'll report that as a percentage, which means multiply by 100. And it is customary to present percentages to the 10th of a percent. So this would be reported as 67.1%. Now you're probably thinking, man, somebody told me statistics was hard. I hope it stays this easy. It's not going to, but enjoy it while it lasts. All right, average, there's 91. So we have 91 divided by 316, multiplied by 100. Focus on the tenth, so this would be 28.8%. And the 13 divided by 316 times 100. I'm going to do everything in one shot there. So we have 4.1%. Now I'm not rounding up the 0.1 like I did previously because the digit in the hundredths is not 5 or bigger. So just a little review on rounding. Now these things will typically add up to 100, but sometimes because of rounding they don't. But I can already go ahead and tell you that in this situation it appears that they are. Yeah, so 100.0%. Now, I say sketch a pie chart and a bar chart. Now, guys, if I was ever going to do something like this in a presentation, I wouldn't sketch a pie chart or a bar chart. I would use technology. And I'm going to show you how to do that a little later in this video or maybe even the next video. But if I was going to sketch a pie chart, and I think it's advantageous to sketch a couple of these to see where they come from, see some interesting characteristics, and then once we create these things in StatCrunch, it makes it hopefully make a little bit more sense. So what I would do in a pie chart is I would do my best to draw a circle, and that actually isn't bad. And I just think about, well, where's approximately the center of the circle, which would be there. And what I do is I just kind of divide the circle into 4 equal pieces, 25% of the circle. So what I want to do is I want to try to take the percentage of each one of the classifications and draw the proportion in terms of pies that corresponds to the percentage of each of the groups. So in other words, I want 67.1% of my pie to be shaded as low, 28.8% of my pie to be shaded as average. Well, I can think about 28.8. I try to find the one that is closest to either 0.25, 50, 75%, and 28 is. So I could let this be a little bit more than 25%, give it some sort of unique shading here, and I would call this the average because that's exactly what it represented, the average risk level. Now I realize that of the rest I have 67 and 4%, so I have just a very small portion, 4%. Now if I think of 25% here, 4% would be about 1/6 of that. So I just try to kind of come in and think, where would 1/6 be? And again, I'm just trying to sketch this. I'm going to shade it with something different, and I'm going to let this stand for the high risk level. Then I'm going to come in the other part and shade it with something different, and this would be the low risk. So what you get is you get just at a very, very quick glance that the proportion of the pie that again corresponds to the percentage of each of the levels of risk level, each of the stocks or classification, the retirement funds. Where that they correspond to the percentage of the pie. Now again, guys, these things sketched by hand are actually pretty ugly. Mine was, and actually that's one of my better ones. But still, they're never that pretty. But when we do this, and I'll show you how to use these on StatCrunch, they actually turn out to be a very, very effective way of getting a snapshot, a quick visual of the percentages of the classifications. Now, let's focus on a bar chart. A lot of people confuse bar charts and histograms. Remember, bar charts are specific to categorical variables. Histograms are specific to quantitative variables. The big difference is in a bar chart, the bars don't touch. In a histogram, they do. So what I would do here is I would draw the upper quadrant of the rectangular coordinate system, and I would put on the vertical axis the levels. Let me try to make this a little clearer. And then I would put on the vertical, I would put the percentages. Well, I see that my percentages run up to about 67%, so I probably would run this if I was doing this by hand, which oddly I never would. I would run this from 25 up to 100%. So low, 67.1% is going to be about right there. I always like to kind of shade them so they pop off. Average 28.8, so that's going to be a little bit above the 25. And the high is going to be 4.1%, which is not very high at all. Now, it turns out that we also here have a Pareto chart, because a Pareto chart is nothing more than a bar chart when the values are arranged in descending order. So this low, average, high kind of did have a natural ordering, but because it's classified as a categorical variable, I could have put these in any order. It makes sense again to go low, average to high, but imagine if we had a categorical variable like gender, male and female. There's no natural ordering there. Political party, Democrat, Republican, Independent. I just mentioned Democrat first because alphabetical order, but it doesn't have to be that way. In a Pareto chart, the ordering is required according to the highest bar first, the next highest bar, and so on and so forth. Okay? Now, let's say that we had a little bit more information about these 316 retirement funds. Classified not only by risk level, but let's say we have them classified by risk level and whether or not they were a growth or a value classification. So you can see we still have 316. We still have 212 that are classified as low, 91 is average, and 13 is high. But now we've separated each risk level into whether or not it's a growth or a value. So of the 212, we can see that 143 was a growth, low risk. 69 was a value, low risk. And we can just go on and complete the table. Now, there's three ways that your textbook teaches to classify these. First of all, you can summarize the frequencies by displaying as a percentage of overall type, percentage of row total, or percentage of column total. And one of the main purposes of this video is to teach you how to do that, or at least to demonstrate how to do that. Now, if we're looking at the percentage of overall type, what we're doing is we're taking each one of these cell counts and dividing by 316. So if I take 143 divided by 316, multiply by 100, we would have 45.3%. The average, 74, divided by the total, would be 23.4%. And guys, we would just continue doing this for all of the cells. So what would happen with this cell right here? Well, exactly what we think. We would go to that number of 91, divide by the 316, and we would have 28.8%. And guys, obviously this cell is 316 divided by 316, so there would be 100.0%. Now, contrast that with the next type where we do the percentage of row total. Row total is pretty much focusing on the rows, and in this case it's just focusing on the percentage of growth and value. So for this cell right here, we focus on the 143, but we're dividing by the total row, or the row total for growth, which is 227. So 143 divided by what did I say, 227, gives me 63.0%. That was kind of a tricky rounding. The next would be 74, again divided by the 227. So 32.6%. And just to choose kind of a random square here, random cell, we do the same thing. We take the 13 divided by the 316 and get 4.1%. Now, notice that on the row totals, that when we get out here, we're going to have 227 divided by 227, which is going to be 100% and 100% and 100%. But notice that the row totals here aren't 100%. Because again, we would have 212 divided by 316. I know you guys are thinking, man, I hope statistics stays this easy. It's not going to, but enjoy it while it lasts. So 67.1%. Now, the way when I publish things and are involved in publications, it's customary with most styles of writing to round percentages to the nearest tenth of a percent. However, if MyMathLab wants you to round to the hundredth of a percent two places, then do so. Don't miss the question just because of rounding. Now, the remaining thing we have here is we want to look at the percentage of column total. So essentially what we're doing here is we're focusing on risk level. And luckily, the stuff that we learned, the way we learned how to do the percentage of row total applies to the percentage of column total. So I would take the value of 143, and instead of dividing by 227, which is the row total, in the column total, I would divide 143 by 212. So I have 67.5%. And I'm not going to bore you with this. I can do all of these. Let's just for the heck of it, let's go down here and see what this one's going to look like. We'll take 13 divided by the row total, which is 13, is 100.0%. I should have actually used 0.0 up here too to be consistent. So in the column totals, all for actually obvious reasons, the columns all have 100%, where in the row totals are 100%. So guys, what would this cell right here look like? Well, it would take that number, which is 227, divided by the column total of 316, and we get 71.8%. All right. Now let's jump out of this, close this down, and look at something that's really much more applicable to the types of things we run into in statistics when we actually go out and collect data. And I found this data set some time ago, and I thought it was kind of interesting. It's called Belief, Party, and Gender. So let's download this thing, and let's open it up, take a look at it. Someday. And I want to make it a little larger so everybody can see it. And I don't know why, but I found this kind of a really interesting data set. First of all, we have party. Then we have variable belief, and we have a variable gender. Now, clearly, all of these are categorical because party, the way they've provided here, I think, is just Democrats and Republicans. Belief is either pro-life or pro-choice, and then gender is either male or female. All right, so not only would it be interesting, and guys, something else I like about it, it's a very large data set. I think like 850, no, more than that actually. I guess 880 subjects included. But anyway, something very important when we look at a data set. And guys, this is super duper important. So tattoo this stuff to your brain. The first thing I notice are I have three variables: party, belief, and gender. These things vary. Party is Democrat and Republican, belief is pro-life or pro-choice, and gender is male or female. Now, when a statistician looks at a data set like this, we tend to read up and down. Up and down are the variables. So when I look at this data set, I think, what percentage are Democrats? What percentage are Republicans? What percentage of this sample is pro-life? What percentage is pro-choice? What percentage is gender? What percentage of the subjects are female, and what percentage is male? I also would kind of like to come in and look at a contingency. See if there's any relationship maybe between belief and gender or party and gender. Now, kind of contrast that with how most people, and statistics shows this ironically, most people when they read a data set, they read left to right. And that's the number of subjects. That gives us the number of subjects if we come down and look left to right. Left to right gives me information about one person. This person here is a Democrat. They are pro-life, and they are a female. Compared to, come on down a little bit, this person right here is Democrat. They're pro-life, and they are a male. Somewhere along the line, we're going to run into somebody pro-choice. There's a Democrat, pro-choice, and that person is a male. So statistics shows that when people without a statistics background pick up a data set like this, they read left to right. That's information on an individual. When people in statistics pick up a data set, they read up and down. This is the variables. So guys, in this case, we have three variables. They're all categorical. And we have, I think I said 880. Was that right? Yeah, I think 880 subjects or individuals. Now, the first thing I want to do is I want to save this, and I want to save it on my desktop so it's easy to find. And it's saved as a .csv file, which is fine. And I'm just going to leave it as party, belief, and gender. So I'm going to save this. Because what I want to be able to do is I want to be able to get into StatCrunch, and I want to be able to import this data set into StatCrunch and be able to analyze it. That stuff I did over there a while ago with the growth and value funds across the risk level. You know, doing all that by hand and doing the pie charts, which was ugly and not precise, doing the bar charts. Yeah, I want to use StatCrunch. I want to use a statistical software package to take care of end goals like that. All right. So that's what I'm going to do now. I'm going to get into MyMathLab. I'm going to sign in. And I'm going to go to our site. All right, so I'm going to go to StatCrunch. Again, this is our statistical software package. And I am going to go to the StatCrunch website. Now, what I want to do is, typically we're going to use one of two things. I can either type or paste the data, but in this situation, I want to use the top link, which is select a file on my computer, namely select a file on my desktop. So guys, the best way to learn is to follow along with me. Now, the files that we have the choice of dropping there can be .xlsx, all these other text file, TSV, but notice .csv is an option. So I want to go get it, so I'm going to choose it. I put it on my desktop so it was easy to find. And then I will come down and I'm going to load the file. I'm going to get a little spinning wheel that tells me that it's trying to load the data into StatCrunch. And you can see now it's in StatCrunch, so it's in now to where I can analyze my data. All right, first thing I may want to look at is just one variable at a time. Let's look at party. What percentage are Democrat and what percentage are Republican? Guys, this stuff needs to go in your notebook because it's going to be, when we're out here week 3 or 4 and we're looking at regression models, and you need to very quickly look at a categorical variable and try to find out the frequency and percentage. You don't want to have to go back and watch old videos. You just want to thumb through your notes and get that information very quickly. Well, it turns out it's very easy to do. I can go to Stat. I can go to Tables. And I can go to frequency. Now this is what I do if I want to just look at frequencies and percentages for one variable. If I want to get into a contingency table, then I have to use this. So I'm going to go, for now I'm going to walk before I run. So I'm going to go to frequency. And right now I just want to look at party. And I want to come down and I want to look at frequency. And I have a max, so I'm going to choose shift, and I want to look at, I want to do frequency and percent total. Frequency. So it says command click. All right. So you see when I hovered over what I wanted, it popped up in yellow. It's shift plus click if I'm working on Windows, I do believe, and it's shift command plus click if I'm working with a Mac. All right, guys. Nevertheless, I've got what I want, so I can do this for a party. So I can hit compute, and I can see that 550 of the 80, which is 62.5% of my sample, is a Democrat, and 330. Which is 37.5, is a Republican. So almost 2 to 1, not quite, but almost 2 to 1 Democrats, 2 Republicans. I also may want to look at the other variables, and it turns out that I can go to frequency and I can actually include all the variables. And I can come here and just look at frequency and percent of total and hit compute. So when I get that very quickly, not only do I see that I have 550 Democrats and 330 Republicans, the belief, whether people are pro-choice or pro-life, is almost 50-50. 54.5% are pro-choice, 45.5% are pro-life. We can come down now and see that 450 are female, so that's 51.1%, and 430 are male, which is 48.8%. Now, I think the interesting part comes, though, when we start looking at our tables and looking at the contingency. So contingency we're going to do with data because we have a data set. If I had the summary like I did before, then I could go with summary. But I don't have that here. I got with data. So I would like to look on the row, I would like to look at the party and see what the relationship with party and belief. Okay? Now I don't want to group anything just yet, but what I want to look at is I want to look at the row percent, the column percent, and the percent of total. Now, we're going to ultimately get into chi-square test of independence, but right now we're not going to do that, and we'll get into Kendall's tau and lambda and stuff like that soon enough. But right now I just want to take the data set and statistically describe it. Look at relationships. So when I hit compute, I'm going to find out some pretty interesting stuff. I thought that would get larger. I can see that of pro-choice, pro-life versus Democrat and Republican, that 400 out of the 880. So the count is 440. You can see that it gives you four things, and the cell format is provided here. So I have percent of total, so 45.45% of the subjects were Democrat and pro-choice. Only 17.5% or 17.05% were Democrat and pro-life. Republicans, only 9% was a Republican and pro-choice, and 28.4% was a Republican and pro-life. Now that's a little bit deceiving, because really what we want to look at is we want to look at the column percents, because we'd like to know, compare across Democrat and Republican, or at least I would, what the percentages are versus pro-choice, pro-life. So if I focus on the column, and the column is the third value given, I can see that 83% versus 17% of those who are pro-choice, 83.3% are Democrat, 16.7% are Republican. However, pro-life, you can see that 37.5% are Democrat and 62.5% are pro-life. Now, I think that's kind of interesting, because I find that a lot of people, Republicans and Democrats, tend to be so because of single issues. And I think abortion, beliefs about pro-choice, pro-life drive a lot of people's political affiliation. And you can agree with me or disagree, that's fine, but I think that, well, just based on my experiences, I see that a lot. Now, I'd also like to maybe take a look at the relationship between gender and belief. So again, I want row percent, column percent, and percent of total. Now, again, ultimately, we'll get into this expected count and all that fancy stuff, but right now we're just surviving. And it's over there so far I can't see it, so let's see what we have. Well, again, looking at the column percent, we can see of those that are pro-choice, it's about evenly split. 51.25% are female, 48.75% are male. It's almost evenly split on pro-life, 51% versus 49%. So we don't see a lot of disparity, a lot of difference in pro-choice, pro-life across gender. Now we'll ultimately get into things, are relationships statistically significant? And I'll talk about that a lot more at the proper time, but we would not have statistical significance here, meaning that there just doesn't appear to be any relationship between whether someone is pro-choice or pro-life and their gender. Now, on the other hand, if we go back and look at the beliefs across political party, it does seem like 83.3% versus 16.7% is a big disparity between those that are pro-choice. In fact, if you're pro-choice, very, very likely you're going to be Democrat. If you're pro-life, most likely you're going to be Republican. So we would probably get statistical significance there, but it's kind of irrelevant to talk about that now because I haven't yet taught that to you. Now, something I want to do is I want to go work a problem, and a problem that I want to work You know what? I'm not going to be able to do that just yet, so forget that. I'm going to have to download the problem, and I'll work it in the next video. All right. So guys, that's all for this video. We'll do more of this stuff in the next video. So take care.